So I've been quite interested in these magnet motors that have been appearing on YouTube. A lot of people experimenting with permanent magnets to see whether you can get continuous rotation using just the permanent magnet field, obviously, which is a very low carbon means of producing electricity when attached to a generator. And there are a lot of videos where people are trying to make these work, and in most cases you get to a gate point where you can get the attraction coming all the way around and increasing magnetic field, and then it stops at the largest one and doesn't want to continue to the next. And I saw this crop circle picture, and given that I was interested in the magnets, it occurred to me that this looked like it could be something which was trying to depict a permanent magnet motor. Now, the theory being that this larger magnet and the smaller magnet here on this ring are sandwiched between an internal increasing field, then starts again and increases again, and the external increasing field here, and then increases again here. So there's a gate here, a gate here, a gate here, and a gate here. And when this potentially gets through to the gate, the smaller magnet being attracted to the larger ones here and here will continue to be pulled, and therefore will pull this through the gate. That's what occurred to me when I looked at it. So I set about seeing whether this was something that was actually possible. So I mapped that circle in Fusion 360, and you can see that as we move around, these two would be connected to each other, and this is the rotor with the large magnets on the internal and the external being the stator. And as they turn, when that larger one gets to a gate, which would be here, the smaller ones being attracted to this and also being attracted to this, and the theory being that those two attractions are large enough to pull this through this gate, because it's also been attracted here and also being attracted here. So that's the theory as I saw it. And now you can't, unfortunately, get magnets in all these sizes that are growing in the exact ratio that is depicted here. And so I thought that an alternative to that would be to have a single magnet, then two magnets, then three magnets, because as you put magnets together, the force, the magnetic field actually increases, and therefore we can use that as a simulation of magnets growing in size. So the rotor would be half of the stator, and that would enable us to experiment with different numbers of magnets here, and then placing the secondary smaller magnet, which would be 1 magnet deep, and this would be say 5 or 6 magnet deep, to get the ratio the same as we're seeing in the crop circle. And that would enable us to experiment with different positioning and different numbers of magnets to see if anything made any difference. And then the stator, I had the internal rows and the external rows, and then we'd start with 1 magnet here, then 2, then 3, then 4, etc. Stopping here, and then starting again 1, then 2, then 3, etc. Coming back around again. And similarly in here, we use the same spacing differential, which is that we're seeing on here. So the internal one will be offset by 180 degrees. So when this is the maximum 15, this would be starting over here at 15, and then we'd have 1, 2, 3 again, sorry, at 8, and that would stop here halfway. So we'd have 8 again, and then we'd have 1, 2, 3, 4, 5 and growing. So that's what I built, and I've 3D printed this, and I've put all the magnets in, and what follows are the experiments of the results of that. If others want to have a look and use this to as a potential design that could be optimized, I'm going to put as many videos of the results of what happens when we play with this to see what happens, and I hope it helps you out. Thanks. Just putting this together now, I'm going to experiment with different configurations. But what we're doing here is we're increasing the magnetic field as we go around. So this is 1 magnet, so there's all spaces in the bottom, and then 1 magnet at the top, which you can see down below, space, space, space. And so 1 magnet, 2 magnets, 3 magnets. So the magnetic field is increasing as we go around. And I've taken this to 14 magnets, and then we start again on position 1. The rotor, I've got this in with various slots because we're going to have, these are 5 magnets in here, so creating a strong field. And I'm going to experiment with having a single field up here, so 1 magnet. And when we orientate these central magnetic fields, they're going to be offset by about 180 degrees from the main exterior. The theory being that the smaller magnetic field is attracted to the next set over here, which helps to pull this first one through the gate. So if we just take it round, you can see what happens. So it's being pulled all the way around through the entire magnetic increasing field and stopping 1.5 magnets before the final one. And then to get that through that gate, it's quite a significant bit of resistance. We're on a 1 now, and then it's free here. So now it's just free, and if I just nudge it round, when we get to the first one, it's attracted all the way around through the increasing magnetic field. So that's stage 1. I'm going to complete this, wait for more magnets to arrive, and then we'll see how it works. Okay, so if I move this till it starts to get attracted, whoops, it gets stuck on the 10. Just do that again. That one went through. That one got stuck earlier. Got stuck on the 10. Stuck on the 10. Stuck on the 7. Went through to the 13. 12.5. 12.5 again. 12.5 again. 12.5 again. Stuck on the 7. If I then increase the magnetic field by adding additional magnets to the first part, and then try it again, goes through to the 13, goes through to the 13, goes through to the 13, goes through to the 13. So it becomes more stable. So increasing the magnetic field does make a difference to the continuous rotation, and that initial magnet at the front does enable the attraction. This is attraction on the top and attraction on the bottom, so the whole thing is attraction based. So you can see that it begins to get pulled by that first magnet as it hits the number 1 on the increasing magnetic field. So I'm waiting for some more magnets to arrive, and then we'll see if we can find a configuration that does make a difference. So now we have 5 in the back and 2 in the front. sticking at the 7 in the front. And it's just at the 9 on the back. And the 10 on the front. Sticks at the 7 again. And the 8. So both are engaging the middle two at the worst points. So that needs to be adjusted. Eight, and just before the 8 again. Just before the 7, just before the 8. Just before the 7, just before the 8, and at the 9. Just before the 7, just before the 10. Seven, 6, 5, 5, so it should still be being attracted on that one. And it should be still being attracted in the middle of that one. But it's being held up just before the 8. But I almost wanted to go further. Two magnets, two magnets, two magnets. That is close. The 8 on the inside is easy to get past, but then the outside, which is that 11, there's quite a bit of resistance. That is tantalisingly close. Look at the 14. So those three are definitely pulling it a lot further through the 14. Without the 3, it would be at 12.5. And it's then encountering another resistance points on the inner one. Possibly we need to lose this inner circle completely. Three magnets, the one in the center opposed to the other two, attraction down on the bottom one, which makes it easier to push past this section, and it came almost all the way through. Interesting. Is that just because of different amount of resistance? And there's a lesser strength of magnets or something else? Okay, back to basics. Just start with a single ring of magnets, which is rising from 1 to 15, so 1 magnet, 2 magnets, 3 magnets, all the way around to 15. With a rotor that has 2 magnets on an attraction basis, sticks on the 15 and then gets attracted from the 3, comes all the way around and back to the 15. If you take it to the 4, that gets attracted. If you take it to the 5, that gets attracted and pulled around. 6, attracted and pulled around. 7, attracted and pulled around. 8, attracted and pulled around. 9, attracted and pulled around. 10, attracted and pulled around. and the 11 stops a little bit. There's no longer any attraction, and then there's resistance at the 13, 14. That's actually with 3 sets of magnets. Let's try that again. So on an attraction basis, with just one set, it gets hung up. So 4, 5, it's attracted, 6, it's attracted, 7, it's attracted, 8, it's attracted, 9, 10, 11. Right, so from the 12, it's now a tiny bit of resistance. When we get to the 15, heavier resistance. 1 still heavy. 2, it goes all the way and nearly wants to come through. So 2 sets of magnets. If we have a steel rotor, it starts being attracted from the 1, 1.5, and gets pulled around, 2, 3, 4, 5. It's being attracted all the way around and stops at 7. 8, it's okay again. 9, it's being attracted. 10, 11. Okay, so 11 it stops. Push it to 12, still stops. 13, resistance starts, a little bit though. 15 to 1 is a lot, not huge, but a little bit of resistance. And then if we let it go, it bounces back off the 15 again. So that's just with steel. This one has 3 magnets with the middle one sandwiched like poles between the other 2. So attracting on the bottom, and then on top of that it's repelling the middle one. Then above the middle one it's repelling the top one as well, which adjusts the magnetic field. So 15 is where we've got a little bit of repulsion, but not much. About the 3, it starts to get attractive, but not a huge amount of force. But equally now there's not a huge amount of resistance. 3, it still wants to go. 4, it wants to go. So it's still being attracted, still being attracted, still being attracted. And then it stops. Whoa. It's kind of freewheeling between 11 and 13, 14. Then a little bit of resistance starts again at 15. And then from about 3, it goes. So if I spin it, but again, the resistance is virtually matching the force of the propulsion. So as the attraction reduces and the repulsion that at the gate reduces, they kind of match. So it isn't, although we can get it all the way around once, the force is balanced and it doesn't want to go through. So that's just on the 3 configurations: metal magnets on their own on attract, and sandwich magnets. So the sandwich magnets reduce the force of the field, but retain an attraction most of the way around.